12,800 years ago, something ended. The megafauna of North America, mammoths, mastodons, ground sloths, short-faced bears, disappeared within what the geological record shows was a remarkably short window. The Clovis people, the earliest well-documented culture in the Americas, vanished from the archaeological record at almost the same moment, and the climate, which had been warming steadily as the last ice age released its grip, reversed, sharply, dramatically, and plunged the northern hemisphere back into near glacial cold for more than 1,000 years. Geologists call this the Younger Dryas, named for a small Arctic flower, Dryas octopetala, that recolonized Europe as the cold returned. It is one of the most abrupt climate transitions in the entire Holocene record, and for decades the mechanism behind it was assumed to be understood. Then a group of researchers started looking at what was in the dirt. The belief in its most careful form goes like this. The Younger Dryas impact hypothesis, the YDIH, proposes that roughly 12,800 years ago, a fragmented comet or asteroid struck the Earth across multiple sites simultaneously. The impacts, or the airburst events above the surface, triggered continent-scale wildfires, injected enormous quantities of soot and debris into the stratosphere, disrupted ocean circulation, and initiated the 1,000-year cold snap we call the Younger Dryas. The strongest version of this argument does not stop with climate. It argues that what we lost in that event was not just megafauna, that's somewhere on Earth, and the proponents point most often to coastal regions now submerged under the post-glacial sea level rise. There existed a culture or network of cultures sophisticated enough to have seeded the later flowering of civilization in Mesopotamia, Egypt, and the Indus Valley. The abrupt, unexplained emergence of agriculture, the sudden appearance of monumental architecture at sites like Göbekli Tepe in Turkey, dated to 11,500 years ago, and built with a technical sophistication that has no clear precursor in the archaeological record. This is not a fringe argument made only in podcasts and best-selling books. The impact hypothesis itself was published in the Proceedings of the National Academy of Sciences in 2007 by a team led by Richard Firestone of Lawrence Berkeley National Laboratory. The paper named 26 authors, geologists, physicists, archaeologists, and presented physical evidence from across North America, Europe, and the Middle East. The evidence they cataloged included elevated concentrations of iridium and platinum, elements rare in Earth's crust but common in extraterrestrial objects, found in sediment layers precisely dated to 12,800 years ago. It included microspherules, tiny glass and iron beads formed when rock is instantaneously melted and resolidified, the signature of extreme impact heat. It included nanodiamonds, specifically a form called Lonsdaleite, which forms only under the pressure and temperature of cosmic impact. And it included a layer of black sediment found at hundreds of sites across 4 continents that the researchers called the black mat, a layer marking, with unusual consistency, the boundary where the megafauna disappear from the record. The strongest piece of physical evidence may be a single archaeological site in Syria. Abu Hureyra, one of the earliest known agricultural settlements on Earth. In sediment layers dated to the Younger Dryas boundary, researchers found melt glass with a formation temperature estimated above 2,000 degrees Celsius, higher than any known natural process on the surface, higher than the temperature of a volcanic eruption, consistent in the literature, with only 2 explanations: nuclear detonation or cosmic impact. Here's the pillar. The single scientific requirement for the Younger Dryas impact hypothesis to be true is that its physical markers, the platinum, the microspherules, the nanodiamonds, the melt glass, must appear at the same stratigraphic horizon, consistently across multiple continents, and that horizon must date reliably to 12,800 years ago. That is the test. And it is a hard one, because stratigraphy, reading the layers of the Earth, is not simple. Sediment moves, layers get mixed. Erosion and bioturbation, the churning of soil by organisms, can displace material by centimeters or more over millennia. A platinum spike found 3 centimeters above where it should be is a platinum spike that may mean nothing at all. When the scientific community examined the 2007 Firestone paper, the initial response was largely skeptical. Multiple research teams attempted to replicate the findings and could not. A 2009 paper by Pinter and colleagues in the journal Geology examined 17 sites cited in the original study and found they could not reproduce the nanodiamond or platinum concentrations at many of them. A 2010 analysis by Suravel and colleagues, published in the Proceedings of the National Academy of Sciences, the same journal as the original, tested 10 sites and found the proposed impact layer in only 2, and questioned whether those 2 were genuinely anomalous. The critique carried weight because of where it came from. These were not YouTube skeptics. Suravel is a paleoanthropologist at the University of Wyoming. Pinter is a geologist at the University of California, Davis. Their objections were methodological, about contamination protocols, about whether the markers being measured were genuinely impact-derived, about the statistical significance of the anomalies relative to background levels. By 2012, the consensus position in geology and archaeology remained what it had been. The Younger Dryas was caused by the disruption of the Atlantic meridional overturning circulation, the ocean conveyor belt, by a massive pulse of glacial meltwater flooding into the North Atlantic. No crater, no impact. A climate event caused by the physics of a planet ending an ice age. And that is where the story would have ended if the data had stopped accumulating. The data did not stop. In 2012, a team led by James Kennett of the University of California, Santa Barbara, one of the world's leading marine geologists, published a paper in the Proceedings of the National Academy of Sciences reporting the discovery of nanoscale diamond crystals in sediment layers at 12 sites across North America, Europe, and the Middle East, all from the same stratigraphic horizon, all dated to 12,800 years ago. Kennett's team had found lonsdaleite, the hexagonal diamond polymorph. This matters because lonsdaleite had never been found in terrestrial, volcanic, or geological processes. It had been found in meteorites. It had been found at the Cretaceous-Paleogene boundary, the layer that marks the asteroid impact that ended the dinosaurs 66 million years ago. Finding it at the Younger Dryas boundary across 4 continents at the same stratigraphic level was not a minor result. The Kennett paper was followed in 2013 by a major review paper published in the Journal of Geology, authored by 29 researchers from 9 countries, which analyzed material from 23 sites on 4 continents and concluded that the evidence for a cosmic impact at 12,800 years ago was consistent and reproducible. Then came the platinum. In 2018, a paper published in the Journal of Geology by Christopher Moore of the University of South Carolina examined a single site, the Younger Dryas boundary layer exposed in a peat bog at White Pond, South Carolina. Moore's team found a platinum spike at the boundary layer that was 24 times higher than background levels. No volcanic explanation, no known geochemical process that concentrates platinum in surface sediment, consistent with an extraterrestrial source. The same year, a paper in Scientific Reports documented a platinum anomaly in the Greenland ice core at the Younger Dryas boundary, the same ice core record that provides the most precise climate chronology available for this period. Platinum is not mobile in ice. It does not migrate. Finding it in Greenland ice at a specific dated layer is not ambiguous stratigraphy. In 2019, a study published in Science Advances examined sediment from beneath the Hiawatha Glacier in Greenland. and found a roughly 31-kilometer crater that had been hidden under the ice. The age of the crater was initially uncertain, but subsequent analysis suggested it may have formed within the last 800,000 years, possibly much more recently, a 31-kilometer impact crater under the Greenland ice sheet that nobody had found before because it was buried under a kilometer of ice. But the site that has generated the most focused attention in the literature is Abu Hureyra. Abu Hureyra is a tell, an archaeological mound, in what is now northern Syria on the banks of the Euphrates. It was excavated in the 1970s by Andrew Moore of Rochester Institute of Technology before it was flooded by a dam reservoir. The site showed continuous occupation from approximately 13,000 years ago through to the early Bronze Age, an extraordinary stratigraphic record. In 2012 and in a more detailed follow-up in 2018, researchers including Moore, Kennett, and Alan West, a former geologist now working as an independent researcher who was also a co-author on the Firestone paper, published analysis of material from the Abu Hureyra sediment layers. What they found in the layer, dated to 12,800 years ago, was unusual. Melt glass, microspherules, and temperature indicators. The melt glass at Abu Hureyra showed formation temperatures in excess of 2,200 degrees Celsius. Volcanic activity in the region, around 1,100 degrees. Wood fire, around 900 degrees. The only surface process that generates temperatures above 2,000 degrees is a nuclear detonation or a cosmic impact or airburst. The researchers argued it was consistent with a low-altitude airburst, a comet or asteroid fragment that detonated in the atmosphere above the site rather than striking the surface, similar to the Tunguska event in Siberia in 1908, but orders of magnitude larger. The debate in the literature has not resolved, it has deepened. Critics of the YDIH have continued to publish. A 2018 paper by Holliday and colleagues in the journal Paleoamerica argued that the markers are not consistently distributed across sites, that the dating of individual sites has been questioned, and that the meltwater hypothesis remains the most parsimonious explanation for the Younger Dryas onset. Supporters have responded point by point. A 2021 paper in Scientific Reports by Bunch and colleagues presented evidence from Tal El Hammam in Jordan, a Bronze Age city that shows signs of a catastrophic destruction event dated to approximately 3,600 years ago, with physical markers including melted pottery, vaporized minerals, and a platinum anomaly. The paper argues this site preserves evidence of a second, smaller cosmic airburst event, demonstrating the mechanism is real and physically plausible. The YDIH debate has now accumulated more peer-reviewed publications on both sides than almost any other hypothesis in quaternary geology. It is not a fringe claim that has been dismissed. It is a contested hypothesis that has been examined intensively and remains genuinely open. Here is what the evidence says. There is something in the sediment at 12,800 years ago. Platinum anomalies have been independently confirmed at multiple sites. The Greenland ice core platinum spike is real and not contested. Nanodiamonds of a type consistent with impact have been reported across 4 continents at the same stratigraphic level. The melt glass at Abu Hureyra formed at temperatures that require an explanation, and no geological explanation has been offered that accounts for those temperatures. What the evidence does not say is what hit, where it hit, or how many pieces there were. No crater has been definitively linked to 12,800 years ago. The Hiawatha crater in Greenland is suggestive, but its age has not been precisely established. The distribution of platinum across sites is consistent with multiple airbursts rather than a single ground impact, which makes physical sense for a fragmented comet, but makes it much harder to find the smoking gun that settles the debate. What would change the consensus? The researchers who have argued for the YDIH have said it clearly. A crater, specifically a crater dated with high precision to 12,800 years ago, at a location consistent with the distribution of impact markers. That has not been found. Under the ice, under the ocean, in a desert somewhere waiting for a survey, it may exist. It has not been found. And then there is the civilization question. The impact hypothesis is separable from the lost civilization hypothesis. You can accept one without the other. The physical markers in the sediment say nothing about whether anyone sophisticated was alive to witness the event. The question of a prior civilization depends on the archaeological record, and the archaeological record for the period immediately before 12,800 years ago is genuinely thin. Not because the evidence has been examined and found absent, but because most of the coastal land surfaces that would have been inhabited during that period are now underwater. Sea level at the end of the last ice age was roughly 120 meters lower than today. Every coastal settlement, every shoreline camp, every tidal habitation site from that period is sitting under the continental shelf, unexcavated, in most cases even unsurveyed. The honest position is this: something happened at 12,800 years ago that left markers in the sediment across 4 continents. What exactly happened is not established. Whether what happened ended a civilization is not established. Whether that civilization existed is not established. But the physical evidence in the dirt is real. More than 60 peer-reviewed papers have now reported findings consistent with the YDIH. More than 30 have argued against it or questioned its markers. The debate is alive, methodologically serious, and unresolved. The Younger Dryas door is open. What is on the other side of it, we do not yet know. The Younger Dryas impact hypothesis is not settled science. It is not discredited science. It is contested science, which is where the most interesting questions live. If you want to follow this debate as it develops, subscribe to Hard True Science on YouTube. New episodes every week, and follow us on YouTube at Hard True Science.